Hello everyone, welcome to Unravel Logic YouTube channel. In today's video, we'll cover the concept of conditional probability. Conditional probability. To understand this concept, you need to be aware about the concept of probability. I have created a video on probability. You can go and watch it first in case you are not familiar with the concept of probability. So let us start with the formal definition first, as usual. Conditional probability is the probability of an event B occurring given that an event A has already occurred. Okay, so let me repeat. Probability of an event B occurring given that an event A has already occurred. It is denoted as probability of B given A. This has already occurred. Now you need to find out what is the probability of B given that A has already occurred. Next, let us go ahead and see the mathematical formula. It is given as B given A. To find this, what we need is P of A and B, which is A intersection B, over probability of A. Obviously, probability of A should be greater than 0, otherwise it would be a mess. So this is probability that A happens and then this is probability of both A and B happening together. So this is total favorable outcomes, and then these are the events we are interested in. Okay, let us understand more. Okay, so when we say that given A has occurred, so when we make a statement like given A has occurred, what are we really saying? We ignore all outcomes where A does not occur. We are ignoring all the outcomes where A does not occur, and we treat A as our new sample space. Okay. In other words, out of all the cases when A happened, how many cases also satisfy B? In all the cases when A happened, how many cases also satisfy B? Now, one question that you might be asking is, why is it P of A intersection B over P of A instead of simply P of B over P of A? So, why is it P of A intersection B over P of A and not simply P of B over P of A? So, let us understand that. This is because we are taking all the cases where A can happen. A can happen, which is P of A, okay? And then finding out all the cases where B can happen given that A has already happened. So that would be P of A intersection B. Okay. So if I draw a quick Venn diagram, so this is A, this is B, and then this is A and B. So to find out probability of B given A has already happened, we need to first find P of A intersection B, which is this part, and then divide over all the ways that A can happen, which is this whole thing. Okay, so this whole will be your sample space, which is P of A, and then the only way where B can happen given that A has already happened is this part, and this is nothing but P of A intersection B. So that is the reason we do P of A intersection B over P of A and not P of B over P of A. Okay, this is incorrect, this is correct. Now let us take an example to understand this better. Let me take it on a new page. So, example. Consider a deck of 52 playing cards. Deck of 52 playing cards where event A is that the card drawn is a face card. Event B is the card drawn is a king or K. What we need to find is P of B given A, which is given that a face card is drawn, we need to find the probability of that card being a K or king. So let us start. Given the formula that we have, we first need to find probability of A, which is our sample space, which is nothing but the probability of drawing a face card. This one. Okay. So how many face cards do we have? So before that, how many total cards do we have? So we have a total of 52 cards. Out of those 52 cards, how many face cards do we have? So we have 4 J's, we have 4 Q's, and we have 4 K's. So that gives us 12 face cards. Okay. Now what is the probability? So which is 12 over 52, total cards 52 and then 12 face cards. So let us not simplify it, but simply write it 12 by 52 for now. Okay. Now P of A intersection B. Okay. So out of 12 face cards, how many are the kings? Okay. So out of 12 face cards, how many are the kings? So how many kings are there? 4 kings. Okay. Total face cards, we have 12. So the probability would be 4 over 12. Okay. So this equals P of A intersection B. Okay. So 4 by 12 ways this can happen, that the card drawn is a face card and it is also a king. So what is the conditional probability of B given A, given that you have drawn a face card, it is a king? So by the formula, which is P of A intersection B, which is 4 by 12 over P of A, which is 12 by 52, that gives us 4 by 12. We simplify it, gives us 1 by 3. So that is the probability that if you have drawn a face card, the card that you have drawn is a king. So it's the probability is 1/3. Okay. So in other words, if I simplify it more, conditional probability filters the sample space based on the given condition. It reduces your sample space. Okay. So one edge case is where A and B are independent events. There is, so when we say independent events, we mean that there is no relation between the events A and B. In those cases, P of B given A will equal simply P of B, and vice versa, P of A given B will simply equal P of A, because A and B are not related to each other and won't filter the sample space. If either of the event happens, it won't affect the other event. Now, this concept of conditional probability is a very important part of Bayes theorem. So when we'll cover Bayes theorem, it would be very crucial that you understand the concept of conditional probability. So watch this video once again if you would like, but do understand this concept, do your own research, try to find your own examples and think about this. And thanks for watching. Please like, share, comment and subscribe. It would really motivate me to create more videos. Thank you.